And the topic of today's lesson is Ohm's law. Ohm's is a guy. And so we capitalize his name whenever we write Ohm's. Ohm's law, you just need to remember, V is equal to IR. So that's going to be a formula that's going to show up on your formula sheet during a test. I'll expect you to be able to solve for any variable in Ohm's law. If you know any two of these, you should be able to figure out the third. Voltage, volt was a guy too, we capitalized his name, V, is measured in volts, V. Current is measured in amps. There was a guy named Ampere. We just abbreviate Ampere and call it amps. And the units are, we say A for amps when we're writing the units. Resistance is measured in ohm. We're going to have a little yoga moment here. Ohms. OHMS. And the symbol for ohms is omega. The Greek omega. The Greek omega. Once we know this relationship, we can actually make some calculations. So there is a problem set in your future. And I'm showing you some of the basics. It doesn't get much more simple than this. This is a series circuit, and it's very similar to the series circuit that you built in the circuit construction kit, except I've replaced the light bulb with a resistor. Well, the light bulb is a resistor. A light bulb is just a fancy resistor that glows. Right? This is a resistor that it doesn't glow. It's not a light bulb. But it's providing some resistance to current flow. Again, use the analogy of a river. If the river is straight and there's no obstructions, it's going to go pretty swiftly. There's going to be a lot of current flow. But if you begin to put rocks in the river and the river makes turns, then there's going to be a resistance to flow. That's why we draw the jagged or the zigzag line for a resistor. So whenever you see a zigzag line, you think, oh, there's resistance to current flow. There's a resistor here. And it has some value in ohms. Right? In this particular problem, I have told you what the resistance is and what the current is. Can you calculate and tell me what the voltage must be to drive this circuit? Let's do that. Get out your calculators. This is physics class. Let's calculate the voltage. Guys, when you graduate and you think about on your experience in high school, and you think about the one thing that you learned in science, is that Mr. Adamatis taught you how to be a good guesser. Right? So we're going to guess. I've written a lot of given information here. That's our G. U, what is our unknown? What are we trying to solve? Voltage, that's our unknown. GUE, we need an equation. Ta-da! Ohm's law. So V is equal to, let me write it over here. V is equal to the current times the resistance. GUES, substitute what we know. The current is equal to 0.004 amps, times the resistance of 1,000 ohms. Ohms, I'm making room for my little symbol ohms because I like to draw my little symbol ohm. And so what's that going to be?
4 volts.
4 volts. Easy peasy lemon squeezy, right? You have just analyzed your first circuit. You are now an electrical engineer. How about that? And so what I want you to do is you're going to write another circuit, and this is going to be, you're going to call this a series circuit. Okay? In a series circuit, we have two resistors, R1 and R2. R1 is equal to 3,000 ohms. R2 is equal to, 2,000 ohms. All right, we're going to make the numbers nice and round, so we're going to have a voltage of 100 volts. And we want to know what the current flow is. Here's what you need to know in order to solve this problem. Yes, current is equal to the voltage over the resistance. But really, when I write Ohm's law, and you might want to write this in at the top of your page, R total. because you're very seldom, if ever, going to have a circuit with just one resistor. So you're going to have to add up all the resistance in the circuits. Oh, I just told you what to do. Our total, we handle it differently for series and parallel circuits, so I'm just giving you a heads up. In a series circuit, so our total series is equal to R1 plus R2 plus however many resistors you have. In this case, it's going to be, let me do it like this. Voltage over R total, which is going to be R1 plus R2. Right? And so that is going to be the voltage, which is 100 volts, divided by 2,000 plus 3,000, right, is equal to 100 volts over 5,000. 0.02. 0.02 amps. Okay, so this is an example that we're working through. There's going to be a problem set in your life where you'll have to do this for yourself. I want you to have an example. Okay, now I'm going to draw a parallel circuit. You're drawing a parallel circuit. Let's use our same resistors, except this time I'm going to call R3 and R4. And R3 is going to be the 2,000, and R4 is going to be the 3,000. And we're going to use the same voltage is equal to 100 volts. And I'm going to ask you, what is the current flow through a parallel circuit? Using the same resistors, it's going to be a different answer. Current is still equal to voltage over our total. We need to have total up here, right? But this is going to get kind of messy. In fact, if you know where the inverse button is on your calculator, you're going to become very familiar with it. Because our total for a parallel circuit our total parallel, 1 over, we're going to call them R3 or an R4, I guess. R3 plus 1 over R4. There's another way to write this. You can write 1 over R total is equal to 1 over R3 plus 1 over R4. Right. I think for simplicity's sake, most textbooks show it like this because then I could say, well, it's however many resistors you have in parallel. In our particular case, our total is equal to 1 over R3 plus 1 over R4. Now you got to get your order of operations right when you enter this in the calculator, or you're going to get a different answer than somebody else. There's two ways to write this. Right now we're writing it like this. So when you write that in your calculator, our total, we're going to have to figure this out. You can say 1 divided by, and then you get the quantity 1 over R3 plus 1 over R4, which is equal to 1 over, gosh, this is going to get messy, right? 1 over 2,000 plus 1 over 3,000. Right, so if you're doing it in your calculator, you might want to use those parentheses so that you make sure that it gets the right order of operations. So our total parallel, did you get 1,200? Anybody else get 1,200? Okay, got 1,200? Good. All right, so these are doable.